Hi all, I am going to start a new thing, that is motion under gravity. Basically under this we will study motion under gravity in vertical direction, in horizontal and vertical direction. So from this only we can start to projectile motion. So let us consider motion in one dimension and motion under gravity. So very important concept I want to share. Let's say this is ground A and this is top level, ground level B. So while we are throwing a ball from A to B, we can assume that we have to give some velocity here. Let's say we are giving some velocity u at A and it is reaching at the top point B and the velocity will be 0. Because if the velocity will not be 0, it will again go higher. Since it is coming back, it is going like this and coming back. Since it is going like this and coming back, so initial velocity is u and final velocity will be 0 while going from A to B. So motion from A to B, initial velocity is there, final velocity is 0, and time taken will be called time of ascent, TA. It is the climbing time from ground level to top level, so time of ascent. And acceleration is always g, acceleration due to gravity, but it will be taken as minus, because why minus? You know the formula, v equal to u plus at. So u has some value, but v becomes 0. Since u is becoming 0 after some time ta, it will be 0 u minus gta. So something has to be subtracted from u, else it cannot be 0. From a positive thing, if you are subtracting some negative thing, then only it will become 0. So this is motion from A to B. When the ball is coming back, that is motion from B to A. Now initial velocity will be 0. Motion from B to A, I am reconsidering it. Initial velocity will be 0. Now final velocity will be there. Because if you are jumping from a two-story building, don't practice it in home. Or if you are throwing a stone from the two-story building, when it is falling at the ground, a sound will come. So velocity will be not 0. Velocity is maximum. That will again be realized in our work power energy chapter and discuss conservation of energy. So u will be 0, velocity will be there. Time of descent t equal to td, and now a equal to g. So my concept of the day is, suppose you are throwing this with a speed u, the ball will hit the ground with the same speed u. Only difference is here u is uj cap, it is vertically upward direction, and here u is minus uj cap, it is vertically downward direction. It means the velocity is changing but speed remains constant. So initial speed of throw equal to final speed of hit. The body is thrown with a speed u or with a velocity u, it will hit the ground with the same speed or with the same velocity. Means velocity are same in magnitude but direction are opposite. This is the first concept. Second concept, time of ascent equal to time of descent. We have to justify it. So let me consider from A to B. Motion from A to B, initial velocity u, final velocity 0. Now let's say time taken is time of ascent ta. Now acceleration equal to minus g. So my formula v equal to u plus at. So 0 equal to u minus g ta. So u equal to g ta implies ta equal to u by g. So in equation 1 I got time of ascent equal to u by g. Okay, when the ball is going from A to B, let's say it is covering a height h. When it is coming from B to A, it is also covering the same height h. So you can use the second formula, that is s equal to ut plus half at square. So s is h u. Okay, while I am using this formula, I can use in other way. Let's say I am now considering motion from B to A. This will be easier. When I am doing motion from B to A, my initial velocity is 0. When the ball is coming from B to A, here initial velocity is 0. So now final velocity, let's say v. Final velocity is v. Acceleration is g, and time of flight or time of descent is td. So now formula v equal to u plus at. Now v equal to u is 0 plus gtd So V equal to G TD. Now TD equal to V by G, equation 2. Now again I want to use this AS equal to UT plus half AT square for this particular case, motion from B to A. So AS is H, now UT, U is 0 into T plus half. For A I am taking G and for T I am taking TD square. So this is also TD. Why TD? Because this is motion from B to A, this is climbing down, time of descent. So H equal to half into G into TD square. So I got TD square equal to 2H by G. So TD equal to 2H by G root over. So time of descent equal to 2H by G root over. So now again I will come back to motion from A to B, and I am going to use this formula V square equal to U square plus 2S. Motion from A to B. I am climbing up with a speed U from A, and when I am reaching at B, my final velocity will be 0. So 0 equal to U square minus 2GH. So 0 equal to U square minus 2GH. So basically U square equal to 2GH. So since U square equal to 2GH, I can put this formula U square equal to 2GH, or for 2H, okay, I am changing it a little bit. U square by G equal to 2H. I can use this equation 4 in equation 3. In equation 4 I got U square by G equal to 2H. So for 2H I want to put U square by G. So my TD using 4 in 3, we will get TD will be root over. For 2H I can use U square by G divided by G. So TD will be U square by G square root over, implies TD will be U by G. So I got time of descent is U by G. Now already I have got time of ascent is U by G. So now let's say this is equation 5. Now from equation 1 and equation 5, I have realized from 1 and 5, I have realized time of ascent equal to time of descent. So why I am deriving? In order to justify my concept. But the important concept you have to remember, when I am throwing a ball from ground to a top level, the initial velocity of thrown equal to final velocity of it in magnitude, only direction are changing, but time of ascent equal to time of descent. Suppose the ball is going from ground level to this much top level, so time of ascent equal to time of descent. Time of ascent equal to time of ascent. This has already been proved. Now we have to prove, look, again you can look, we have found that time of ascent equal to time of descent. Let's say this is equation 6. So equation 6 is time of ascent equal to time of descent. Now equation 2 is TD equal to V by G. Equation 1 is TA equal to U by G. But if I take equation 1, 2 and 6 at a time, if I take equation 1, 2 and 6 at a time, what will I get? 1, 2 and 6. From 6 I can write TA equal to TD. From 1 I can write TA equal to U by G. And from 2 I can write TD equal to V by G. So GG cancel, so U by V. U equal to V. So remember this concept. Whenever I am throwing a ball from ground to the top, throwing a ball from ground to the top with some velocity, suppose I am throwing a ball with a speed U from the ground, it will hit the ground with the same speed U, and the time of ascent by the ball equal to time of descent. So now I am going to discuss about river boat. This is one kind of two-dimensional motion, so I am entering into two-dimensional motion. Okay. So river boat, let the river is flowing from west to east along this direction. So velocity of river is taken as VR. Velocity of river. I will not do any mathematics here. I will just tell you the concept. You can solve problems from FC Verma or Racing Candidate, and you can ask me doubt in the comment section or in my WhatsApp number. So let's say the river is flowing from west to east. we have to cross the river. I'm giving some name. We have to cross the river. So Vm, let's say I want to cross the river. This is the velocity of man in still water, or okay, in still water. When water is at rest, I mean velocity of man in the pond, because pond water is at rest, rest water or still water. Okay, now the man is trying to cross the river and going from A to B. So two different cases are coming. Just remember the two different cases, and it is little bit logical and reverse of simple case. First one is shortest time. Second one is shortest distance. And it is a case where we are consuming more time in covering shortest distance. Shortest distance is nothing but A to B. The river is flowing in this direction. So when the river is flowing in this direction, when the man is going in this direction, the water current will repel the man along this direction. So the man is to flow like this. The man is swimming like this, and the river is flowing like this. Man swimming, river flowing. Man swimming, river flowing. Man swimming, river flowing. So man will be displaced or drifted towards right. So shortest distance means man is interested to reach at B, which is exactly opposite to A, and AB is the shortest distance. Shortest distance is nothing but AB. So man has to swim like this. This should be the direction of swim of man by making an angle theta with the vertical. So man has to swim by making an angle theta with respect to vertical to reach the shortest distance, and in this process the man will take maximum time, because every moment the man is swimming, the water will be drifting like this. Man is swimming, water is drifting like this. Man is swimming, water is drifting like this. Man is swimming, water is lifting or shifting him and make him reach here. Now shortest time, and here longest distance will be covered, or you can say maximum distance. Why? If the man starts swimming as it is, suppose he is starting swimming like this, simply swimming in this direction, then water will shift him in this direction. So the man will reach here, AC. So this is the longest distance covered by the man, while it is trying to take shortest time, because it is not fighting against the water. But simple thing, the important thing, this is very simple thing, but after this the complicated thing is, remember this, I will use this in projectile concept. When the man is going from A to C, let's say he is consuming time T. In that T time, the man is covering AB distance and also the man is covering BC distance. They are not same. AB is not equal to BC is not equal to AC. But I can write a concept. Time taken by the man to go from A to C equal to time taken by the man to cover AB distance equal to time taken by the man to cover BC distance. Suppose the man is taking 10 minutes to go from A to C. In that 10 minutes the man is covering AB distance, and in that 10 minutes the man is covering BC distance. This concept will be useful in solving problems. If you come across or try to solve problems from H.C. Verma, then my last concept is very, very important. Distance are not same. We are observing 3 distance, but they are same in terms of consuming time or time spent. Thank you.